So why don't we go through and we'll change these values and see what we come up with.
So what I did is we made this so that you could actually do this in front of a customer, and we'll use the numbers that we just discussed, 20 cents per kilowatt hour. We'll use $3.80 per gallon of oil. We're going to use $2.70 per gallon of propane. Use $1.25 per therm of natural gas. We're going to use $265 per ton of wood pellets, and we'll use $200 per cord of wood. So what all this does is it takes all of these numbers and it calculates everything into BTUs, which is a unit of measurement of heat. So getting everything into the same unit of measurement to get what would the total cost of 1,000,000 BTUs be for any of those sources of fuel.
Okay, so we buy 1,000,000 BTUs, this is what it's going to cost us.
Correct.
Electric heat at $58.60, oil at $37.70, propane at $35.09. Wood pellets, $19.49. Wood, $13.07. Natural gas, $17.36. Okay, so those are what most people are using in their home for heat. Okay, and then when we look at the Mitsubishi heat pumps, we have them broken out in COP 2, 3, 3.5, and 4. Can you explain that, why we have that broken out?
Well, COP is a acronym for coefficient of performance. So coefficient of performance is how does the heat pump compare to electric resistance? Because a heat pump is it's an electric appliance. So we have to have the ability to compare it to other sources of fuel, so that's where coefficient of performance came in. So a coefficient of performance of 2 means that the heat pump is twice as efficient as electric resistance, which will be at certain temperatures outside, because as the temperature outside goes down, the coefficient of performance goes down. So coefficient of performance of 3 would mean that a heat pump is 3 times more efficient than electric resistance, and a coefficient of performance of 4 means it's 4 times more efficient than electric resistance. So really that's the only way that we could compare our system to other sources of fuel, is by having something called the coefficient of performance, which is basically taking the amount of energy that you put in, compare that to the amount of energy you get out.
Okay. Before we move on to the slide that you showed me earlier about weather data, on average, what COP are we going to be looking at for operation?
The average coefficient of performance over the course of the entire winter is going to be around a coefficient of performance of 3.
Okay.
The majority of the winter you're actually going to be up around coefficient of performance of 4, but then there will be those cold snaps, then we'll be down near 2.
Okay.
So that's why we say that the average will be around 3.
Okay, so if we look on an average of 3, okay, $19.53, okay, we are always more efficient than propane, we are always more efficient than oil, and we are always more efficient than electric heat by a lot.
By a lot.
We're competitive with wood pellets, and we are close to gas, but when you look at a COP of 4, okay, we are better than gas, okay?
Right, so anytime that the temperature outside is around, say, above 35 degrees, we will be better than natural gas.
Okay.
And even some of the systems could actually be more efficient to a lower temperature. It's really the other sources of fuel that it becomes very obvious that we're the better solution. You know, when we're looking at oil, and we are almost 50% more efficient than oil the majority of the winter. And the same with propane. We're about 50% more efficient than propane for most of the winter. There are going to be periods where it's going to be comparable to oil and propane, but that's going to be when the temperature is about 10 to 15 degrees, which it doesn't get 10 to 15 as much as people think that it does. Many people around here think that it's very, very cold in New England, but it isn't as cold as people think.
Okay. While we're here, I just want to point out the wood pellets in Mitsubishi Electric cooling and heating, because a lot of people in New England get excited about wood pellets, and I like wood pellets for a lot of reasons, but We can't get air conditioning out of wood pellets, can we?
You can't get air conditioning out of wood pellets, and also for wood pellets, you're generally, in this scenario, is assuming it's a wood pellet stove, not a wood pellet boiler, because if we were to introduce distribution losses into the equation,
Right.
now we would actually be more efficient, the majority of the time. Plus, with our system, it's controlled by electricity. So really, you set a temperature, you forget it, you can leave the house. If you have a wood pellet stove, and you don't have wood pellets in it, it's going to go out.
Yeah, it's an automatic system.
It's
and we
ours is
don't
an automatic.
and we don't have to store wood pellets.
And you don't have to store wood pellets.